Space is filled with stars, galaxies, and swirling clouds of gas. But strangely, most of the universe is made of something we can't see. A silent, invisible structure that shapes everything we know. Astronomers call it dark matter. And tonight, we trace the ghostly footprints of a force that may be holding the entire cosmos together. Welcome back, traveler. Let's step into the invisible universe and uncover what lies behind the darkness. Imagine walking into a room where everything looks normal, but nothing acts the way it should. Galaxies behave just like that. They spin too fast, tug too strongly, and stretch too far apart. Something unseen is adding extra gravity. Something powerful and everywhere. Astronomers first noticed this cosmic oddity in the 1930s. Galaxies were moving as if they had hidden mass, far more than their stars and gas could explain. The galaxies weren't breaking apart, because something invisible was holding them together. Today, we believe dark matter makes up 85% of all matter in existence. Not stars, not planets, not atoms, something entirely different. If we removed dark matter from the universe, galaxies would collapse like sand slipping through open fingers. Dark matter doesn't reflect light, absorb light, or emit light, but its gravity shapes the universe. Like a hidden skeleton, it forms an enormous web, and galaxies cling to it, growing inside its vast cosmic branches. If you spin a frisbee, the outer edges move slower. But galaxies don't follow this rule. Their outer stars move just as fast as the inner ones. A dangerous speed, strong enough that without extra mass, the galaxies should tear themselves apart. Sometimes, dark matter betrays its presence by bending light. When a galaxy cluster passes between us and something far behind it, the background light warps, stretched into arcs and curves. A cosmic fingerprint of something invisible. One of the strongest proofs of dark matter came from the Bullet Cluster. Two galaxy clusters collided, sending their gas clouds crashing together. But the mass, the gravity, drifted ahead, ignoring the collision. Only dark matter behaves like that. Dark matter isn't black holes. It isn't dust. It isn't a trick of gravity. All of those have been tested, and none fit the evidence. Whatever dark matter is, it must be something entirely new. Something outside the atoms that make us. Deep underground, in ultra-cold labs, scientists are listening for tiny taps of dark matter particles hitting detectors. So far, silence. But silence doesn't mean absence. The universe is patient, and maybe dark matter is too. If dark matter is everywhere, what is it made of? Could it be a single particle? A whole family of unknown forces? Or something stranger than we can imagine? The deeper we look, the stranger the dark becomes. Because dark matter isn't just hiding in deep space. It's around us right now, passing through your body, through the earth, through everything. Every second, trillions of dark matter particles may be drifting through you like silent ghosts, leaving no trace behind. If dark matter is everywhere, what is it made of? Could it be a single particle? A whole family of unknown forces? Or something stranger than we can imagine? For years, scientists pursued the idea of WIMPs, weakly interacting massive particles. They were the perfect fit. Heavy enough to add gravity, gentle enough to avoid detection. But decades of experiments turned up nothing. No collisions, no signals, only questions. Then came the axion, a strange, ghost-like particle so light it barely interacts with reality. If axions exist, they could form enormous clouds surrounding galaxies, influencing everything while revealing nothing. Experiments now listen carefully for the faint flicker an axion might leave behind. Even stranger is the idea of sterile neutrinos, particles that barely interact even with normal neutrinos, which are already incredibly elusive. If sterile neutrinos exist, they might decay into faint X-rays, leaving behind a cosmic whisper that astronomers are beginning to search for. Some scientists imagine something even more dramatic: dark stars, huge ancient stars powered not by fusion, but by dark matter. These would glow faintly in infrared light, hiding in the earliest era of the universe. If found, they could reveal how the first structures formed. Dark matter is more than particles. It is the architect of the cosmos. The universe isn't randomly scattered. It forms a vast cosmic web. Galaxies sit at the intersections like dewdrops on a spider's net. Without dark matter pulling the threads tight, no galaxies would have formed at all. But how do we map something we can't see? Scientists use gravitational lensing, watching how dark matter bends light, to paint a picture of its distribution. The result is a map of ghostly shapes and tangled filaments stretching across billions of light-years. Dark matter doesn't just shape galaxies, it shapes time itself. The universe expands at different speeds depending on where dark matter clumps together. This creates a strange tension in the cosmos, a subtle imbalance scientists are still trying to decode. Supercomputers attempt to recreate the cosmos from scratch using only dark matter physics. The results are stunning: filaments, clusters, voids, all matching what we see in the real universe. Dark matter may be invisible, but its fingerprints are all over the sky. Some theories go even further, proposing an entire dark sector: dark matter, dark forces, dark photons, a hidden mirror universe operating alongside our own. If true, the visible universe may be only a small fraction of everything that truly exists. But all of this leads to a haunting question. What if dark matter isn't made of particles at all? What if the universe is hiding something even stranger? A force we haven't discovered, or a flaw in gravity itself? The answers may change our understanding of reality. Because as we push deeper into the invisible universe, one idea becomes impossible to ignore. What if dark matter is not a thing at all, but the sign of a deeper flaw in the laws of gravity? A signal that the universe is more complex than Einstein ever imagined. Some scientists believe we don't need dark matter, because maybe gravity behaves differently on enormous scales. Modified Newtonian dynamics, or MOND, suggests that galaxies spin the way they do because gravity becomes stronger in deep space than we expect. But the universe rarely follows a single rule. MOND solves a few mysteries, but fails others. Einstein's theory of general relativity explains almost everything, from falling apples to the bending of starlight. But dark matter is a gap, a quiet signal that something is missing in the architecture of physics. Some theories combine dark matter and modified gravity, creating hybrids that stretch imagination and mathematics alike. A radical idea proposes that dark matter and dark energy may be two faces of a single cosmic substance, a dark fluid. In this model, the universe behaves like a strange ocean. Galaxies move through it, guided by currents we cannot see. If true, space itself may be a kind of cosmic sea, shaping the motion of everything inside it. But what if dark matter is leaking gravity from dimensions beyond our own? String theory suggests the universe may have extra dimensions curled up so tightly we can't see them. Gravity could seep into our universe like faint echoes from a deeper reality, creating the illusion of dark matter. Some models suggest the Milky Way might hide a dark matter disk, a flat, invisible structure overlapping our galaxy. If it exists, the solar system would pass through it every 30 million years. Some speculate this could even link to ancient cycles of cosmic events on Earth. To truly understand dark matter, we must return to the beginning. Right after the Big Bang, dark matter spread through the young universe, forming gravitational seeds. These seeds attracted gas, creating the first stars, the first galaxies, the first cosmic structures. Without dark matter, the early universe would have remained a smooth, empty fog. Imagine a universe without dark matter. No galaxies, No stars. No planets. No life. Just endless drifting particles in a silent, featureless void. Dark matter, though invisible, is the silent architect that made existence possible. In the coming decades, new detectors, new satellites, and new theories will push deeper into the dark. The Euclid telescope, the Vera Rubin Observatory, and quantum experiments are preparing to map the invisible universe with unmatched precision. Every new discovery brings us 1 inch closer to understanding the unknown. And yet, a haunting possibility remains. What if dark matter is beyond human reach forever? What if it's made of physics we cannot detect, or realities we can't interact with? The universe may always remain partly hidden, a reminder that mystery is woven into the fabric of creation. Mystery is woven into the fabric of creation. Dark matter is not just an astronomical puzzle. It is a mirror, a reminder that most of the universe lies beyond the reach of our senses, and perhaps always will. But in every mystery, there is beauty. And in every unanswered question, there is a doorway to the next great discovery. And if the invisible universe fascinates you, wait until you see what's hiding inside the fabric of spacetime itself. Because next time we explore the object that defies physics more than anything else, the black hole. Traveler, the darkness still has stories left to tell. Stay curious, and I'll meet you in the next journey across the stars.